So let me introduce Stefan. He will talk about today about what can go wrong with your code and how to correctly find the bugs. Stefan is working at Sentry, so he's using Unity in a professional way. May I ask you, when did you start working with Unity?
So the first time was I was studying game engineering on an FH Technikum in Vienna, and I transitioned from mechatronics to game engineering. So then I wanted to make games, and it was all about, I don't know, performance programming, C++, engineering. I was like, please just let me build games. And then Unity showed up, and it was like a whole new world for like getting stuff running, being able to prototype really fast. And ever since I've been chasing the the Unity life.
Cool. And do you use it also privately if you don't, if you're off work?
To be honest, I used to do a lot more with it, like tiny little prototypes from like roguelikes to something that might look a little bit like Forager. You have a little dude running around, you can swing your axe, you can chop trees. And then scope creeped up on me and killed the idea really fast. Nowadays, with like working on an SDK in Unity,
okay,
it changes the mood a bit.
Yeah. So you dug a much more deeper in Unity than usual, I can imagine.
Yes, so like dealing with build pipelines and stuff. It's a whole new phase of Unity.
I must apologize, Harald, because he got sick, so he will not make it to speak today, but we have our next meetup in June on the 13th. So stay tuned. He will present his talk there. And after the short introduction, Stefan, please, the stage is yours.
Oh, thanks a lot. So I'm just gonna share my screen. All right. So as I said, my name is Stefan, and I'm the maintainer of the Unity SDK here at Sentry. The title today is "Your Games Are Crashing and You Didn't Even Know." And I've got to admit, the title is just maybe a tiny bit clickbaity. But do you really know? I mean, do you actually know what your games are doing out there? Because who's telling you? If you do know that your games are doing fine, then that's really great. Kudos to you. Probably don't believe you, because you have to have some feedback loop. And for those of you that don't know what's happening or what their games are doing out there in the wild, I'd like to invite you to a little journey. So picture this. I'm a game developer. Unity is my engine of choice, and I'm working on the next, I don't know, World of Eldercraft Super Smash Saga. And I brought this little indie Smash hit with me. So as you can see, that's what it's going to look like. No menu screen, just a call to action. So let's play. I've got a tower here. The tower is fighting off the bugs. And once it's killed enough, I get to place a new sentry. So I'm going to put that, okay. Sorry about that. The game crashing when I tried to talk about games crashing. So let's restart that. The tower is doing its thing. Gonna place another sentry, and it's gone again. That's okay. That's cool. Whatever. I didn't want to show it like that. Anyway, I didn't want to play the game. But that moment right here, that moment of frustration, like you have no idea what's going on, that could be, or like it's most likely an actual player's experience. And it's really not good, because as a player, I'm super irritated right now in the best of cases, and I don't even have any options. Like, what am I supposed to do? I already restarted the game. It crashed on me again. I guess I could try reaching out to the developers. I guess I could write them an email. I could write a review. Worst game ever. Keeps crashing. But if I look at it from the developer's point of view, what does that situation mean? It means that you're super reliant on your players telling you what happened and what was going on. It means that you have to rely on them to give you information like, hey, what kind of platform were you on? Maybe questions about the hardware. Maybe, I don't know, did you have an internet connections? Or questions that are even more specific to the situation in-game. What happened before it crashed? Which level were you on? And I guess you could preemptively put all those questions on a loading screen somewhere. So in case something happens, player already know what they're supposed to provide you with. But games are going pretty fast these days, so there's not that much time for putting walls of text for players to read. Alternatively, you could put Sentry into your game. So a little bit about Sentry. First and foremost, it's an application monitoring tool. And that means there's an SDK, and that SDK sits right next to your game. And in case something goes wrong, it captures the wrong, and it captures the whole surrounding context with it, and it bundles it all up, and it sends it to Sentry. On Sentry, you get alerts, and you get notified, you and or your team, about that, like something is going on, like something's wrong. And then you can take a look at it, and you can like figure out how to deal with it. It removes the whole telephone game of a player tells you, hey, it crashed. And you're like, okay, what happened? What did you do? And then you wait for them to respond to that. Especially since all those answers the players are going to give you, they're going to be filtered through their perspective and through what they think is important. Okay, so let's say the crashes before, there were no accident. Let's say I put a bug in there on purpose to demonstrate what Sentry can do for you. So on Sentry, you get a report about the issue, about the crash. And that report consists of a couple of parts. The first is going to be tags. Tags are customizable, first and foremost, but Sentry is already capturing a whole lot of stuff out of the box. Things like the environment, things like operating system, versions of different kind of stuff, version of the operating system, what kind of GPU, maybe information about the CPU. And since this is customizable, you can add your own tags to it. Those tags are filterable. So let's say you put your level as tag, so game crashes, you put your level as tag, and then you can filter on Sentry. If you want to like polish one level, you can filter by that level and then really drill down and polish it to a shine. The next part Sentry is going to give you is called contexts, and contexts are going to go even more in depth about the different aspects of whatever happened on the user's machine. So there's going to be context about the hardware, there's going to be context about users, app, like I said, device-specific metrics, GPU information about Unity itself. And that information right there, that's all out of the box. And as with the tags, those contexts are customizable. So you can put even more stuff on there, like hit points, character level scores, enemy count, maybe even the inventory if that's relevant to your game. The next part that Sentry is going to give you is breadcrumbs. And breadcrumbs is like Hansel and Gretel. Like it leaves a little trail that allows you to retrace the steps the player took leading up to the event that triggered the error, the crash. So as we can see right there, bottom top, the bottom is the oldest one. So the scene changed. There was a scene called game that was loaded. The game flow in this demo is controlled by a state machine, and those state machine transitions, like every state leaves its own little breadcrumb. So we go from the game start, that's where we clicked the button, to game fighting, because the bugs, the spawn, they attacked the little tower. Then we got to pick an upgrade. We selected Sentry, and then we placed the Sentry. And the second to last breadcrumb is game state fighting. And that's already pretty interesting, because from what it looks like, what it looked like to me, I was clicking to place the Sentry and then it crashed. But the breadcrumbs tell a different story. The breadcrumbs tell me that the tower was already fighting against the bugs. But that's coming back to like the player experience, like the player perception between what actually happened and what the player perceived as happened, and then it crashed. So the last the last part of the puzzle is going to be the actual code that was involved in the issue. So that's going to be a stack trace, and bottom to top we have a native plugin called gd.c, and that native plugin that triggered a SIG trap in a method called crashing to make a point, and that already sounds pretty ominous, and I guess it did what it was supposed to do. Right beneath that is a little bit of C++ code that's involved in actually invoking a C++ method, a C method in that case, from C#. And right after that is already Sentry.cs, line 92. That is my mono behavior, that's like my C# script inside of Unity. And we can see that if the game is not paused and the game object's tag is not the same as the initial tower, then we are crashing to make a point. So I guess I already have a pretty clear idea of how to fix that, bug. And I want to point out that Sentry is able to show me that source code because I opted into uploading my source code during build time. If it did not do that, all I would get is the stack trace with the line numbers. So no code highlighting. All right, so that all sounds pretty great. But what do you actually have to do to get all of that? Like all I showed so far is working out of the box. So let me take you on a little demo. Inside of Unity, we have the package manager, and the package manager allows us to install packages from all kinds of different locations. I'm going to choose disk. We do have a GitHub repository. Like I want to mention that Sentry is open source, so you can look at all the source code. You can host it yourself. You can make changes to the SDK and use it as you see fit. I'm going to load this here from disk. Where did I put it? Sentry package open. And while it's installing, what we do get is in the top toolbar, we get screen sharing and compiling. It is awesome. We get a little tools menu. And if it decides to be finished, I can show that up. Wow. So we get tools, Sentry, and then we get a little config window. So that the SDK is self-initializing. If you do that for the first time and you have not set it up, instead of that tool window, there's going to be a little wizard that pops up that helps you like link a Sentry project with your Unity project. That's going to fill out all the relevant like a DSN, like where is it supposed to send those events. And it gives you all kinds of options to like override the environment or the release. If you want to have like different timeouts for different things, if you want to have the SDK put out logs or not. And with that, we're basically done. Like that was the installation. And everything has shown up until now is included in your game. Going on a bit of a technical tangent, it's actually pretty hard to make Unity crash. And for clickbait reasons, I had to use a native plugin to make the game crash technically from outside of Unity. So there are basically always at least 2 layers to every Unity game. And that means there are always more than 2 layers to the SDK. There's the native layer. And the native layer is different depending on which platform you're on. And then there's the managed layer. And that's basically where we live within Unity. Inside of Unity, we usually deal with exceptions. And because we are within Unity, we have access to a couple of really nice things which help enrich those events in case something goes wrong. So you can reuse logs that you put in there during development, like all those debug logs, debug log warning. Another thing that's super powerful in presenting you with the whole picture are screenshots, because right, a picture says more than 1,000 words. But if you prefer words, then we have scene hierarchy. So one thing I want to show off because even though it's a super small game, even that game has an Easter egg. And if you click the title screen, you get to the samples that are included in the package. And then we can just throw all kinds of different errors, because who wants to write bugs? So we throw in our reference exception. So how does that look like in Sentry? I mentioned before the screenshots. So in the background, you can see the tags, and right next to the tags is the screenshot that we capture from within Unity. There's this view hierarchy. So in the editor, you used to have the hierarchy to interact, like use the inspector, select stuff. Technically, that's still there during runtime. It's just invisible. We go through, depending on how big your scene is, we go through it all. And we do capture the individual components on each game object, and we capture the hierarchy, like the relationship those objects to each other. The next part is gonna be because it's an error from a button. It's again another reference exception with line 23. Throwing the null reference exception, I've got to add those are IL2CPP builds, and it works starting with 2020. That you get line numbers with IL2CPP builds, and at that point, Sentry has a whole bunch of additional features, and I would like to highlight two of those before the end of my talk. One of them is called release health. So Sentry allows you to write them. If you don't overwrite the release, it grabs it from the app version during the build, and it allows you to help you track those updates and patching, those patches when you're shipping. So you can see the adoption rate, like how many events, how many sessions are getting sent from users during the lifetime of your game, and it shows you the crash-free rate. And as you can see, that's version 2 of that game with a crash-free rate of 63%. So it's not doing all that hot. It even has a little flame next to it telling you stuff's on fire. But that's okay. I mean, that's for demonstration purposes only. And the second feature I've been working towards is performance. And that already works out of the box for the startup and all of the scene loading and all await calls of all game objects during startup and scene loading. So we hook up into all kinds of different things, and we capture how long does stuff take, how long does an awake call, like if you transition to a new scene, how long does it take for all the game objects to awake, basically. So to sum up, what Sentry can do for you is it broadly captures the context surrounding any error. Doesn't matter native, doesn't matter managed, it captures all it can do. It automatically creates tags for you, and those are customizable and you can filter by them. It creates breadcrumbs for you. There's stack traces with line numbers. There are screenshots, so you do get a picture, an actual picture of what happened during the event of a crash. It gives you the scene hierarchy, and there's release health and automated performance monitoring. So open source, use it.
Great, Stefan. Awesome. I have for sure a question. Like, do you know the performance impact from specifically mobile devices and VR setups? Because I think these are the most critical ones in regards of either performance or memory. How much space on the one side does the Sentry plugin take up, and how much performance does it cost to monitor all that stuff?
So it sits idle in the background, and it doesn't do anything until something goes wrong. So in case something goes wrong, the performance hit is like, it's debatable. Like, do you take the performance hit for the information that it provides to you? The size, I don't know by heart, but we do have CI set up in a way where it outputs on the GitHub repository, it outputs the memory footprint, like even though app bundle size and stuff like that. So that's all super transparent. For Unity specifically, I would have to look it up because it's not that little. A couple of megabytes for sure.
Okay.
So it does add a couple of things because it's all those layers. Like on Android, you have the managed layer, you have the native layer, you have the Java layer, you have the layer underneath the Java layer. So it's a whole bunch of SDKs that will increase the bundle size a bit. And
by sending packages home, do you know what's the average size for an error message?
That's
or do you
just
bundle?
Yeah.
Or do you bundle several at once?
Like each event gets sent individually. There's offline caching in place. So in case you're, especially for mobile, if you're offline, you can't send it. So it saves it to disk. And the size of those events, if you can add attachments, so that skews the size. So if you choose to add something, screenshots, for example, you have control over the resolution, and that's an attachment. But the event itself is like, I don't know, 7, 10, 15 kilobytes.
Okay.
It's not that heavy.
Any questions from the audience? Danny.
I have a lot of questions. So, I mean, I took a few notes. For example, regarding the data collected, I guess that this is something that when you use such a service, you need to do like the same like you do, for example, for any analytics service too. No? So you have to request consent GDPR wise to the user. Hey, I'm tracking everything what your system is, no? So I guess that's expected or explaining what you are using.
There's a difference between like user specific data and like general data about the state of your game at the time of the crash. Yeah. And by default, Sentry doesn't send any PII related information. Like that's all removed or like not captured. So you're not able to track a user based on Sentry.
Yeah, I mean it's aggregated data anyway, no? But it still is collecting the data, no? So the user need to consent, no? Otherwise it's it's wrong. Okay. What about the you mentioned, for example, that for C code highlights, you need to, when you upload the build, and you have to consent that Sentry store the source code or something like that.
Mm-hmm. Yes, you have to opt into that.
And that is kind of like hosted in Sentry servers.
Yes.
Is there kind of like explain, I guess, in Git or something, what kind of security is there? Or
I think that we do have quite extensive documentation where like there's a limit to like how much from the SDK perspective I follow the stuff, but there's quite a bit of documentation where that stuff ends up.
Okay, so I guess that if we check in the SDK docs or so, we'll find that. Yeah, awesome. Yes. What about the native code? No, so if you have plugins, it will also catch exceptions in the native code of the plugins and brings you to the line where it was.
Yes.
Okay, so both in native and in the managed code, you were already someone.
Yeah. So and that works for all the platforms that I am aware of.
Yeah, iOS, Android. I was seeing in a screenshot.
Yep. Yep.
Nice. Linking to the questions from Gottfried. So you mentioned, okay, there is a bit of size from Sentry itself for the build, but I guess we anyway have to also make a build at the back build, no, to include that information for knowing, this symbolic for know where the breakpoint in the specific line where it was. Otherwise, it would be all cryptic.
But it's the symbol and the debug symbols that getting generated during build time. And you upload. You have two options. You can either upload. You can opt into automatically uploading them during the build, because you want to use them. Alternatively, you can put them on your own debug symbol server and give Sentry like the link to it, and it will pull them during the event processing. So that all happens automatically.
Okay, but that is something that can be built separate. So you can make a build and at the same time not include the symbolic links in the build and just put them separate and then upload it separate.
Yep.
Okay,
It's getting symbolicated on the server.
Okay. So then that information is not bundled in the, which is good because otherwise it would be also much bigger.
No, that doesn't end up in the in the release.
Okay.
The only, I don't know, like the only thing that makes me a little bit sad is that means that all that line number stuff is only available on the server because we don't have access to all of that information on the client.
Yeah. I mean, but I guess when the whole point, as I see, is that to ship what is happened to the users, no? So in that case, you will be able to see anyway, no? So at least you have to get that information. It's somehow what I see so far is there are much features that in other services that I have seen, like Crashlytics or stuff like that, there are some old one. I guess you guys are taking that off and you have pushed it or a lot of nice features. Like for example, the performance stuff. That's really looking really cool. Yeah. Awesome. I don't know. I don't have more questions. It's looking really cool.
But I hook into that. So because then you said like you have to add the debug information anyhow. So is it possible to have a release build, but only the debug information on the server, so that it's running on, let's say, most best performance? Or
that's what happens.
Okay.
So you build it, and the package has a CLI tool with it.
Yeah.
And during the build, there's a post process, and that kickstarts that CLI tool, and it uploads the symbol that are getting generated during build, and it uploads them to Sentry.
Yeah.
And then when something happens, like you have a regular release build that does not require you to like downgrade and lose performance in any way. So that's something maybe even to highlight. I think Unity in 2023 allows for getting symbol line numbers for ITL builds. But those happen on the client, and those will take a performance hit because it happens like the symbolization happens on the client. That's not the case with Sentry. Like you upload the symbols and it all happens on the server.
Cool.